railway companies of the 19th century worked quite a bit differently from today's. Today, Network Rail own the tracks and sell contracts to the train companies who own the trains to run services on them. But back in the 19th century, the companies owned the tracks, trains, stations and all. As the lines began to meet up, passengers would increasingly have to travel with multiple different companies in order to get to their destination. And the passengers didn't much enjoy having to change trains and buy new tickets every time they passed from one company to another. To make travel more attractive, one company's trains would have to run on the other's tracks. But that required a deal to be struck between the companies. This was done on an ad hoc basis and was becoming increasingly difficult to manage, especially as a journey could require 3 or 4 companies to come to an agreement before it could be run. It didn't help that systems varied wildly across companies. Each operated a different signal system, a different fee per kilometre, and often even their equipment was incompatible. If a train broke down in the wrong part of the country, there would be no spare parts available. It was clear that an independent body was needed to coordinate their efforts. It was to this end that 9 companies got together in 1842 to form the Railway Clearinghouse. The clearinghouse worked fast to create standardised systems and equipment across the companies, setting a manual for signalling and communications procedures, and standards for the engines and the carriages, which would allow each train to run anywhere in the country with a minimum of disruption. They had no legal power to enforce these decisions and could only recommend, but the rail companies knew it was in their best interest to follow them, since following a set of standards everyone can agree on greatly widens the available market for everybody, and is nothing but good for business. When it came to fares, the companies could handle tickets which ran only on their own lines. Through traffic was handled by the clearinghouse, where whole offices full of clerks would calculate what portion of the fee to allocate to each company, based on how much of each track the passenger had travelled along, as well as which company had provided the trains. In the case of goods services, the time spent processing and loading the goods by each company in their respective warehouses and goods yards also had to be factored in. One urgently needed piece of standardisation was the gauge of the tracks. Brunel's broad gauge lines were the main issue there, but there was also the Eastern Counties Railway and the London and Midland Railway, who'd each decided to build their lines 5 feet wide, or 1.524 metres. Meanwhile in Ireland, all 3 rail companies operating there had chosen to adopt a different gauge. This is all well and good when the lines were operating in isolation, but in 1844 the broad gauge met with the standard gauge for the first time in Gloucester. This created a problem known as the break of gauge. As through traffic was impossible at these stations, the passengers would have to switch trains en masse, a situation which could be quite chaotic. But while this was a nuisance for passengers, it was a nightmare for freight. Every single item had to be individually transloaded from one train to the next, a process which could take up to 7 hours. Brunel sorted things somewhat by doing a deal with the neighbouring company to have the line between Gloucester and Cheltenham converted to mixed gauge, which would allow it to run both types of engine. This relieved some of the pressure on Gloucester. But it was clear these breaks of gauge would come again, and a universal solution was needed. Several were proposed, such as roll blocks, transporter wagons, and even variable gauge engines and carriages. Brunel personally favoured designing carriages and containers to standardised dimensions, which could be lifted off the chassis and placed on another, similar to modern shipping containers. But each solution would likely have caused as many problems as it solved. A decision was needed whether the whole network should be broad gauge, standard gauge, or mixed gauge. The government appointed the Gauge Commission in 1845 to decide just that. In an attempt to sway them, Brunel organised a trial comparing the performance of the best of his own engines and the best of the standard gauge. His trial did indeed show that the broad gauge engines were faster, smoother, more reliable, and capable of pulling heavier loads than their standard gauge counterparts. But no performance advantage could overcome the fact that only 13% of the network was broad gauge at this time, and Brunel was essentially asking for thousands of kilometres of track to be rebuilt. And while broad gauge track was relatively simple to convert to standard or mixed gauge, the opposite was not the case. Rebuilding the standard gauge lines would require every track bed in the country to be widened, not to mention countless bridges and tunnels. It was clear from the start there was only one decision the Gauge Commission was going to make. On their recommendation, Parliament set it in law that all mainline services should be built to the Stephenson gauge without an Act of Parliament, but they made exceptions for those built by Great Western, an exception Brunel took as a green light to do whatever he wanted, and he would continue to build broad gauge services for the rest of his life, likely hoping people would come round to the idea eventually. Parliament also set a standard gauge in Ireland of 1.6 metres, or 5'3", an oddity since none of the rail companies there were using that width at the time. It would become known as the Irish gauge. Other standardisation attempts were less successful. In 1841, a goods train ran into a landslide in Sonning Cutting in Berkshire. The train contained several third-class passenger wagons in the middle, which ended up being crushed between the goods wagons, killing 8 passengers and injuring 17. This led to calls for improvements in third-class travel. In 1844, a minister called William Gladstone proposed a plan for the railways to be nationalised to allow for greater control, but this plan got nowhere. He was, however, able to get the Railway Regulation Act passed in Parliament. This stated that the rail companies must run services on all their routes every day that were open to all classes, charged no more than a penny a mile, averaged no less than 19 kilometres an hour, and provided proper seating and shelter for the third-class passengers. But the rail companies were still afraid that the working classes would trash the trains if allowed on regularly. The majority of companies took advantage of the wording of the Act and ran one third-class train a day in a dead hour. These became known as parliamentary trains. For the time being, poor people would have to stick to travelling by goods train. The Act was, however, successful in improving the quality of the third-class wagons. Keen to avoid another headline-grabbing scandal, the companies began providing more robust coaches with better protection against the elements, and attaching them at the back of goods trains so there was less chance of being crushed. Another accident from this era, which led to sweeping changes, happened at the Dee Bridge near Chester. The bridge had a wooden track bed laid on a series of cast iron beams. Cast iron being quite brittle, wrought iron joists were used to strengthen them, but they were insufficient for the task. Its designer, Robert Stephenson, upped the ante 6 months after completion by ordering a large increase in insulating material to prevent the wood catching fire. The extra load proved too much, and the next day a train passed over the bridge and the beams gave way. The engine itself was able to make it to the far side and race to the next town for help, but the carriages were thrown in the river. 5 passengers were killed and 9 injured. The accident made it clear that cast iron was not suitable for building rail bridges with. However, the standardisation effort which has probably had the most effect on our lives was the introduction of railway time. Ever since the first sundials, every town had its own local time, with midday set as the time when the sun was at its highest, which varies depending on longitude. This wasn't a problem in the days when it took hours to get anywhere. As a traveller reached each new town, they would set their watch, if they had one, to match the church clock, and just follow that time. But with the coming of the railways, travel between towns became much faster, and industrialisation meant that minutes suddenly began to matter. This made timetables especially hard to follow and to draw up. It was comparable to air travel in the modern age, but with a lot more variations. Trains travelling east also appeared to be travelling faster than those travelling west. For the Great Western Railway, which covered more longitude than most lines, the situation was especially complicated. To simplify the timetables, in 1840 Brunel ordered for every station to match its time up to Greenwich Mean Time. Most rail companies followed suit. In 1847, the Railway Clearing-House endorsed the idea and recommended it across the board. Soon the whole network would be brought into line. For a while, many towns operated 2 separate times, with 2 minute hands on the town clock, but this led to a lot of confusion. And with so much of life beginning to revolve around the railways, towns and cities began adopting railway time as the town time as well. It was reported in 1855 that 98% of cities followed the railway time, but there were some exceptions. Though Exeter Council had voted to adopt railway time, the Dean of Exeter College, where the town clock was, refused to change the time on the clock for many years. In Oxford, though the town adopted railway time, the university did not for many years, much to the confusion of students. To this day, Big Tom Bell in Christchurch, which used to signal the 9 o'clock curfew each night, continues to ring at its traditional time of 9:05 GMT. Finally, in 1880, Parliament passed the Statutes of Time Act, which set Greenwich Mean Time as a standard across the country. Within a generation, the concept of local time had faded away. After the initial surge in railway building in the 1830s, the 1840s initially saw a lull. The economy was slipping, and the banks were reluctant to invest in schemes. But by 1844, the economy had recovered. What's more, the Bank of England had cut interest rates, making government bonds less attractive for investment. Looking for something else to invest in, investors turned to the railways, an industry with calls for expansion across the country, and there was plenty of wide open country for it to expand into. Values of railway shares shot up, and before long there was a mad scramble to invest in new lines. With the money now coming in, new lines began to be proposed more and more frequently, some by the existing companies, but others by new start-up businesses eager to get in on the market. Such was the scramble to claim parts of the country before anyone else, that many entrepreneurs would grab a ruler and draw a line on a map between two cities they wanted to connect, with the promise to work out a route later. And such was the rush for investors to get in on the market that many of these schemes got the green light anyway. Of course, Parliament had to approve the schemes, but many of the MPs there had railway shares themselves, and were only too happy to rubber stamp the schemes since it meant their own shares would increase in value. At the heart of this all was the MP for Southampton, George Hudson. Already the owner of the York and North Midland Railway, in 1844 he was able to organise a merger with 3 other companies to form the Midlands Railway, the first major rail empire. He rapidly began buying shares in other companies, expanding his interests and drawing in investors for every project he put his name to. What the investors didn't know was that Hudson was essentially running a pyramid scheme. He was paying dividends to shareholders in capital rather than revenue. He used backroom dealings in Parliament to delay the start of many projects, and then used the money invested in these new projects to fund previous ones. He operated plenty of other dodgy dealings, such as taking out loans to get the projects going with money he didn't really have, selling land he didn't really own, and using his various business acquisitions to buy shares in each other, fiddling with their market values for his own ends. Hudson could claim he was technically operating within the law, but this was only because the railways were growing faster than the government could regulate them. The financial bubble would collapse soon enough, but for the time being, the railways could ride the wave of investment and expand at their greatest rate ever. Oxford and Cambridge were each connected to the network around this time. This had the effect of putting the two universities on a par when it came to communications with London. Until then, Cambridge had had to rely on a roundabout system of waterways, while Oxford had been able to access travel directly down the Thames. London also gained speedy connections with the various ports along the south coast. Early lines in Scotland had been short and largely built around goods transport, but in 1842 the first direct link opened between Edinburgh and Glasgow, and it was a great success, proving there was a demand there. The next question was, could they link with England? 2 rival schemes were produced: the North British Railway along the coast to Berwick-upon-Tweed, and the Caledonian Railway, which went south to Carlisle. The North British Railway reached Berwick in 1846, but a bridge wouldn't be built across the river for several years. In 1848, the Caledonian Railway met up with the Lancashire and Carlisle Railway in Carlisle to form the completed West Coast Main Line. For the first time, it was possible to travel from London to Scotland without changing trains. At the same time, other companies were constructing lines extending the network north to Stirling, Perth and Dundee. The 1840s also saw experiments with the concept of atmospheric railways, an attempt to use air pressure to pull the carriages along rather than traction. Essentially, a long pipe would run between the rails, with a slit in the top, but two strips of leather and grease used to create an airtight seal. A plunger would be placed in the pipe and attached to a rail carriage overhead. Stationary engines would be used to pump air into the pipe behind and out of the pipe ahead, driving the carriages along. The concept was based on the sound principle that much of the power output of a steam train goes into moving the engine itself. By taking the engine out of the equation, it seemed that more power could be put into moving the carriages. Experimental lines around 1 kilometre long were built in London, Dublin and Kingston. These attracted the attention of some railway pioneers, who began planning much longer routes. 8 kilometres of the London and Croydon Railway were converted to atmospheric, but most ambitious of all was Brunel's South Devon Railway, running 25 kilometres from Exeter to Newton. It is also generally agreed to be Brunel's biggest mistake. The engines were not as powerful as had been hoped, unable to pull more than a couple of carriages at a time, and each engine couldn't handle more than a couple of kilometres of track. It soon became clear that they actually required a lot more fuel and a lot more power than the mobile engines. The system also proved hard to control, and the carriages would frequently overshoot the stations. But the biggest problem by far was the seal. Try as they might, the engineers could not come up with a design and a type of grease which would maintain a proper airtight seal, and which was not affected by the weather and by trains disturbing it several times a day. Within a few months, pretty much everyone involved, including Brunel, had admitted failure, and the route was converted to standard traction. The London and Croydon Railway, which had much the same problems, followed suit soon afterwards. 1848 was the greatest ever year for track building, with around 1,800 kilometres built. It was also the year when the railway bubble finally burst. There was simply not enough capital to spread around too many projects. What's more, the Bank of England had raised interest rates again, and now government bonds were much more attractive for investment, and the investors started moving back towards them. Of the hundreds of schemes that had been approved by Parliament at the height of railway mania, around a third would never see the light of day, and many new rail companies were rapidly driven out of business, forced to sell their lines to the bigger companies for a pittance. The biggest losers were many middle-class families who'd invested their life savings in this expanding market, only for it to collapse overnight. George Hudson's dodgy dealings were also brought to light. His investors deserted him, and his loans were called in. This forced him to sell his remaining railway assets. Still deeply in debt, he fled to France to avoid arrest. He would finally return in 1865 and be thrown in a debtor's prison. The capitalist boom and bust cycle will continue for the railways for the rest of the century, but greater regulations and smaller areas of open country meant that there would never again be such wild swings as there were in the 1840s. Unlike most financial bubbles, the railway mania left behind a lasting product in the form of the railways it had built. The markets would soon recover, and the railways would be stronger than ever. Join us next time as we look to the 1850s, a decade of further innovations, as well as looking at the impact the railways had on the high street, on literature, and on warfare. Thank you for watching my video. If you've enjoyed it, please don't forget to like, share and subscribe, and to leave a comment. And if you'd like to see more of my artwork, there is a link to my website in the description. It's well worth looking at, if I say so myself. I am currently working on part 4, which should be out in mid-December. A 6-week schedule is a good amount of time for putting together good quality videos. I shall see you then.